To start off this meeting, I would like to bring up a rather inconvenient problem my team has come across. As my employees and I generate the company's programs, all of our time is consumed by manually writing each individual code for the program, leaving no time for anything else to be accomplished. However, I have been considering an idea that may lessen the time needed for writing codes. What if we developed an automatic program generator that would be able to understand English commands and automatically generate the codes to fulfill that command? Thank you for meeting with me, John. As a friend and colleague, I was wondering if I could discuss my plans with you in confidence before my presentation to the public in a few months.
Of course, it's no problem. I've been hearing quite a bit about this automatic program generator you're developing. Many people seem to think it's impossible because it's hard to believe a computer could ever have the ability to understand English commands.
It is true that I have been on the receiving end of a lot of skepticism. But if my generator works, it could revolutionize the use of computers everywhere. The achievements of past and present computer pioneers, including yourself, have replaced pencil and paper with mechanical hardware. However, the human is still left to analyze and break down a mathematical problem into different parts, provide step-by-step controls for the process via a program, write that program in notation best understood by the machine, and coordinate the introduction of the input. These pioneers have created machines and methods that remove the computational chore from the mathematician. However, this chore is replaced by the new burden of writing code, thus turning the mathematicians into programmers. This is why my automatic generator is necessary to the future of computer programming. Once completed, the compiling routine of the generator will be the programmer and perform all the services necessary to the production of a finished program, thus the programmer may return to being a mathematician. Good evening, I'm Grace Harper and I'm here today to share my new development. It is an automatic program generator which I have named the computer compiler. Recently I have published a paper describing the compiler called The Education of a Computer, which you should all have a copy of. To begin my demonstration, I will start with the catalog of subroutines the mathematician is supplied with by the compiler. This catalog of subroutines is a menu that lists all the input information needed by the compiler to look up subroutines, assemble them in proper order, manage address assignments, allocate memory, transfer code, and create a final program in the computer-specific machine code. No longer does the mathematician need to have available formulas or tables of elementary functions. He does not even need to know the particular instruction code used by the computer. He needs only to be able to use the catalog to supply information to the computer about his problem. Along with this, a program generated by the compiler could not only be run as a standalone program whenever desired, it also may be placed in the library as a more advanced subroutine to be used again at a later date to solve a more complex problem. The subroutines library can increase in size and complexity at an exponential rate, thus enabling mathematicians to solve problems once deemed impossible or impractical. Because of this development, the speed at which we the programmers and the computer themselves will make achievements will increase dramatically. In fact, I can already see a future in which programs can be written and debugged in a matter of hours instead of weeks. The future is in the computers.